Now, to learn what's new in Allplan 2025, especially for engineers, I will hand over to my colleague Tim Kuhlmann, communication and PR expert at Allplan, who will guide you through all our online sessions covering structural engineering.
Thank you, Ilona, for this very nice introduction and also the handover of the moderation. Hello, everyone. I'm delighted to welcome you to the engineering stream within the Allplan 2025 launch event. Over the next approximately 1.5 hours, I'm thrilled to guide you through a fantastic lineup of 11 short sessions, an agenda tailored to the interests of engineers from around the globe. Experienced engineers inside and outside of Allplan will show you which new and improved features and tools Allplan 2025 provides to empower structural engineers to deliver buildings and construction projects more productively than ever before. I'm sure there's something for everyone, and you will get great value from all these sessions. Just sit back and enjoy the event. Let's pick up where Chad left and get started right away with our first speaker. Let me introduce you to Gianmarco Baldini, who is kicking off the sessions that show what is new in Allplan 2025, but also provide some user insights, some early user insights from beta testers that had the chance to test Allplan for us. Gianmarco is the owner of Baldini Studio for more than 20 years and gained a lot of AEC industry experience as an architect. He joined the event today to present a consistent and holistic workflow, starting with architectural design and arriving at reinforcement detailing based on a real construction project. So, welcome, Gianmarco. Hello.
Thank you, Tim. Hello, everybody. It's a real pleasure to be here.
Before you start your presentation, allow me to ask you to introduce yourself and your company real quick.
Well, I have started my company more than 20 years ago. It was meant to help architects, civil engineers when they don't know how to do something or they don't have time to do something. So we were helping designers to develop their drawings, architectural design, reinforcement design, and step by step we were more and more involved in implementation of a BIM software into their offices. Allplan and SCIA, of course, are most important ones. So in this presentation, I will show you is a result of a joint effort of very well-known Croatian architects and our team, where our task was to build and provide a seamless workflow between different stakeholders using open BIM approach and connect all the disciplines: architects, civil engineers, reinforcement routers. We succeeded to prove that this workflow from architectural model to analytics and then back to Allplan for reinforcement design is a bulletproof one. And this is no surprise for me since the Nemetschek strategy is an open BIM strategy.
Thanks for the short introduction and also to already teaser a little bit your presentation. Now that we got to know you a bit better, I can't wait to learn how you set up your BIM workflow, starting with the architectural design and eventually arriving at Allplan for reinforcement detailing. So Gianmarco, the floor is yours.
Thanks. Let me show it to you. Here we go. This project is very important to us because we took the real world example and did a real workflow from start to finish. Originally, architects were using Archicad, and then we took over the project and started using Allplan, BIM Plus, AutoConverter, and SCIA Engineer. Then with the results of SCIA Engineer, we go back to Allplan for reinforcement design, after which we export some of the reinforcement back to Archicad application for the full workflow. Important for us is that we did this full workflow on actual building in cooperation with MR2 Architectural Studio, very well-known Croatian architects, with the house that received several world awards. Its unique design threw some challenges in our direction, especially with these sloped walls in the attic. Here you can see the animation in Archicad and how it looks, and this was the starting point for us. So we will be back in Archicad with the reinforcement after our complete workflow. Let's see how it looks when we import it in Allplan. But first, I would like to mention that we used full capabilities of Allplan Cloud As you should know, Allplan Cloud has a set of features and set of tools that enables us a seamless workflow inside Allplan team, but also with other teams and other disciplines. BIM Plus is used for managing the workload inside Allplan team, but also for sharing data between dislocated offices. It brings enormous availability improvement, and with the help of BIM Plus application, we have a complete task management inside our Allplan. When we open a new Allplan project, we choose BIM Plus as the location where the data is stored. After that, we imported the model from Archicad via IFC, and as you can see, it looks great. So if you're a little bit careful how you model and how you export your data, you will have no trouble collaborating. Using BIM Plus as a task management tool, we are now showing the possibility of communication and task management. Somebody decided that this window should be moved or enlarged or in any way edited. This task was created in BIM Plus without the need of any knowledge on how to operate a BIM application. You simply create a task and select a window. You can add a deadline and responsible person. On the other side, the Allplan user sees the tasks, and automatically all the information about the specific window on which the task should be performed is displayed in his Allplan window. After a draftsman or an architect makes the change, it is visible in the BIM Plus application as a new revision of the model. This way, everybody knows who has to do what, and everybody has knowledge about the revisions and what happened in each new revision. This is very important to have accountability and transparency during the whole project. One of the big advantages of Allplan Cloud is also Exchange. Exchange is used as a CDE repository for managing documentation. It is a tool which automatically populates an online documentation repository filled with drawings, PDFs, DWGs, or any other kind of documentation during an Allplan export. We have revision tracking and 24/7 availability on the Allplan Exchange. So during the revision, whenever we want to publish a document, we can export it, of course, into the PDF, we can print it, but we can also send it to our Allplan Exchange platform to be shared among all necessary participants. We have the possibility to add additional data to the document, like who was issuing the document, when it was issued, which revision or index it is, and we can also export multiple file formats in one push of a button. In this case, we are now exporting PDFs and DWGs, and we are allocating the responsible person or who should see the document or set of documents. In this case, with one push of a button, all documentation is exported into the PDF file format and the DWG file format. As you can see, everything is already uploaded to our Allplan Exchange platform. The crucial part in this workflow is AutoConverter, which sits on top of the BIM Plus cloud platform, and it automates the process of transformation from 3D model into analytical model. In that transformation, there are several tasks that should be performed, which are traditionally very time-consuming and error-prone. With a tool like AutoConverter, we can reduce errors to a minimum, and we can automatically clean the model, recognize elements, and define materials. Then we automatically make alignments in nodes, which was the most difficult tasks to operate before using AutoConverter. After we go through these 6 steps, SAF file will be ready for SIA import. In BIM Plus, you open AutoConverter and you choose revision and model on which you want to perform the conversion. First, you clean the model of all unnecessary elements that are not needed by a structural engineer, like smart symbols, windows, doors, and so on. We need only concrete columns, foundations, and all the bearing elements necessary for the calculation. After that, we recognize the elements and we apply adequate materials. Then the model is recognized. Now, we can see the difference between 3D model and a static analysis model. AutoConverter is doing a great job and makes our life much easier and conversion almost automatic. Here we have a both recognized model and aligned model and a structural model displayed at the same time. All we need to do is export the aligned model to SAF file format, which is actually a big Excel file which we can then import seamlessly into SIA Engineer. As you see, no more work is needed inside SIA application because we have a clean and aligned model of structure. After importing the model, we make basic static analysis where we show the reinforcement can also be generated inside SIA Engineer application for some element types. Of course, some tasks as usual have to be done by a civil engineer when they calculate static and earthquake analysis in SIA Engineer. This is a pretty regular everyday job and I'm not going to show it today. After some time and effort of an engineer, the results are ready in SIA Engineer. I mentioned that reinforcement can be generated directly in SIA. After the static analysis, we can reinforce 1D elements like beams and columns. For these elements, we then export reinforcement to Allplan or any other BIM application, which is of course a big time saver. This is just one selected column out of the structure for easy view. We display the internal forces and then we calculate. SIA calculates the necessary reinforcement for that specific column. That means that we can optimize reinforcement for each column as we see fit. This reinforcement can of course be edited. After we are satisfied with bar placements and bar dimensions, we can easily export it back to Allplan using IFC files. In a BIM viewer, the reinforcement is very nicely visible as well. When we import reinforcement from SIA to Allplan, it's treated normally as any other reinforcement created in Allplan application, so it's a huge time saver for a draftsman that does not need to draw reinforcement that was already decided in SIA application. We need just to place it on a drawing sheet and make quantity lists. To complete the circle, we want to show you that the Allplan and SIA generated reinforcement can be then exported via IFC into any BIM application. In our case, this is the original ArchiCAD model. I hope you find it easy as I do. This proves that the BIM workflow really works and that synergy between architecture and engineering plays a big part in workflow optimization, and that we can achieve really big time savings using this synergy approach, using the data that somebody else has produced. Help of AutoConverter and BIM Plus is crucial. Thank you very much for letting me explain this workflow, and if you need any clarifications, don't hesitate to call me directly on my mobile phone displayed here. I wish you the pleasant rest of the day.
Yeah, welcome back. Thank you, Gianmarco, for those valuable insights. The Urban Infusion is indeed an impressive building with a really smart concept behind, but so is the setup of the executed BIM workflow that you just presented. In this workflow, what would you say? Which step is the most crucial one in order to make the entire workflow actually work?
In my opinion, the AutoConverter was the missing link in this crucial workflow, but to have a complete and efficient workflow, every step is important. With availability of AutoConverter now, we have a full and uninterrupted workflow. Important note is that now we have this workflow made easy for every iteration. So we know how many times the design process have to go back and forth between architectural model, between architects, civil engineers for static analysis, and this is very time consuming. Now with the AutoConverter, we can do it many times. We can see the differences in BIM Plus even before we take over the changes into the static analysis software. So we save really a lot of time and a lot of effort by implementing this AutoConverter into our workflow. And the most important, we have control all the time, much more control than before.
I'm very happy that we were able to kind of close the gap with the support of the AutoConverter, and therefore make life easier for you as structural engineers and architects. So yeah, especially with the time-consuming part, and especially also with the keeping the control of the model. So thanks again for being our guest today, Gianmarco, and kicking off this part of the stream with such an inspiring session. All I can say is goodbye. See you soon. Take care. And thanks again.
Thank you. Thank you very much. It was a real pleasure being here. Thanks for inviting me again.
After Gianmarco gave an overview of the BIM workflow from architectural design to reinforcement detailing, we will now take a closer look at the autoconverter. Therefore, I welcome Caitlin Metcalf as our next speaker to the Allplan 2025 launch event. As product manager of engineering analysis, Caitlin contributes to enhancing many of Allplan's engineering design products. She's a US-based structural engineer licensed for over 11 years in California. She has over 15 years of experience in structural engineering design and software development for structural engineers. And Caitlin's design experience includes the full range of engineering design projects. From small canopies to school and medical office buildings, she has helped bring structures of all materials and types come to life. Caitlin, thanks for participating today in our launch event. In the next few minutes, you're going to demonstrate very briefly the most relevant features and functionalities of the autoconverter, our solution to efficiently convert physical to analytical models. Let me ask you a question before we get started with the demonstration. To what extent is the autoconverter the central element in the workflow that Gianmarco showed before?
Thank you, Tim, and hello, everyone. I appreciate you having me. The Allplan autoconverter is central to the engineer's workflow because it automates data format conversions or model conversions. It enhances the efficiency and accuracy of converting those models while reducing manual errors. It integrates seamlessly with various tools, handles large data sets, and supports real-time processing, which makes it scalable and essential for complex projects. By standardizing data formats and streamlining these processes, it can boost your productivity and cost effectiveness, allowing all structural engineers to focus more on their core tasks and improving the overall workflow.
Seems like the autoconverter is indeed a very vital piece to realize a maximum efficient workflow. So I'm very excited to dive into the application now. Caitlin, I hand over to you.
We're proud to introduce the new Allplan autoconverter tool hosted on the BIM Plus platform. This tool allows structural engineers to seamlessly create analytical models from an imported physical model. First, select the model created by the architect or drafter from your model menu in BIM Plus, and then click on the autoconverter tool. The Allplan autoconverter automates the creation of an analytical model through a series of well-defined steps that streamline the conversion process from a structural model to an analysis model. As you can see, the interface is simple and easy to follow. The model is easy to navigate, and the conversion steps are clearly listed at the top of the workspace. First, you select your model, and then you click Next to clean it. This tool allows you to filter out any non-structural modeling elements. Next, you adjust and apply the recognizer settings to define material types and cross-section mapping definitions, which are then applied to the model in the recognize stage, which converts the structural elements into grouped analysis objects for smarter design. Once recognized, you may toggle on the view of the recognized analytical model and their elements to verify the conversion and to check your model. Note that you can go back at any time and adjust your settings. You may apply the recognizer conversion like this in stages based on object type or for the whole structure all at once. The last step is to set your alignment settings and finally align the analytical stick model. The final alignment ensures that all elements are correctly aligned and connected, creating a high-quality analytical model that is ready for structural analysis in minutes. In this tool, the autoconverter displays the local axes orientation of each member and groups the members into common design types. The alignment settings let you adjust the dimension, system lines, and eccentricities of each grouped object type so that you can fully customize the alignment and connectivity of every stick element within the analytical model. These alignments are fully customizable and may be revised and adjusted until you have the analytical configuration that you want. Using these automated steps, the autoconverter supports a more intuitive workflow and enhanced interoperability. By streamlining tasks like cleaning, model recognition, and alignment, it ensures the accuracy and efficiency when converting a physical model. These are things that we know are very difficult to do manually and often produce errors in most of our models. As you can see, this tool offers significant advantages to structural engineers by automating the conversion of physical models into high quality, high level of detail analytical models, which saves us all time and reduces errors. Once you complete the alignment and cleaning, the model can be saved back into BIM Plus and then directly imported into your structural analysis program, like SIA. The Allplan autoconverter handles changes or updates to the original model efficiently through a process of synchronization and revision management. When changes are made to the structural model, the updated model can be re-imported into the Allplan autoconverter. The tool then identifies the changes and updates the analytical model accordingly, ensuring that all modifications are accurately reflected and recorded. Back to you, Tim.
Thank you, Caitlin. Amazing to see how the autoconverter can be already utilized to convert physical to analytical models with very little effort. Before you go, can you please give us an idea of what architects, structural engineers, and detailers can expect from future developments of the autoconverter?
Absolutely, and I'm really glad you asked. We're very excited and looking forward to the future of the autoconverter. In today's world, everyone's projects are getting shorter and budgets are getting tighter and tighter. We know it. So we plan to develop the autoconverter further into the central conversion tool for structural models. These updates include support for additional file types, two-way integration, improved model revision comparisons, and model alignment functionalities, all done still with clear and complete record keeping, to make it easy for the structural engineer to track those changes in real time. By improving the speed and accuracy of model conversion and the models shared among the design team, this helps not only the structural engineer, but everyone on the design team, which we know is an important feature.
Thanks again, Caitlin, for enriching our event today. The combination of current functionalities and improvements planned for the future seem to be very promising. Take care and see you very soon.
Thank you so much. Bye-bye.
With the two opening sessions that both featured the autoconverter, Gianmarco and Caitlin touched already on CR Engineer. In the next session, we want to take on the multi-material structural analysis and design software in more detail. For that reason, we invited Marco De Biasio to the event. Marco holds a PhD in civil engineering and applied mechanics, and before joining Allplan, he spent several years working first as a researcher and then as a structural engineer, contributing to several major projects worldwide in the nuclear and in the bridge sector. He joined the company in 2018 and currently covers the role of product manager, responsible for the whole CR Engineer software. Marco, welcome to the event. Hello.
Hi everyone, and thanks for the invitation to the event.
Marco, why should structural engineers consider to add CR Engineer to their technology stack?
There are several compelling reasons to adopt CR Engineer. Firstly, the comprehensive analysis and design capability of the software. Think at the multi-material design, the advanced analysis, or the extended design code compliance. We are talking about Eurocode, American code, Swiss code, and Brazilian design code. Then BIM integration. CR Engineer integrates well with BIM workflows, facilitating smooth data exchange between architectural and structural models. It supports IFC, SAF, and dedicated exchange links with several major BIM software. Also, CR Engineer is known for the easy learning curve and the high productivity. CR Engineer offers a user-friendly and fully customizable interface that allows engineers to model, analyze, and design structure efficiently. Then, extensive reporting and documentation. That means transparency. CEngineer generated detailed and customizable reports, which are essential for documenting design decisions and ensuring compliance with standards and regulations. And finally, I would say scalability for different project sizes. Whether working on a small residential building or a large infrastructure project, CEngineer scales to meet the demand of the project, making it a versatile tool for engineering firms of all sizes.
Wow, those were pretty lots of good reasons to have at least thoughts on CA Engineer. Even if you don't demonstrate the software to us today due to time constraints, I'm looking forward to getting an overview of the software's range of possibilities and functionalities. So I'm handing over to you. Please give us a little bit a deeper dive into CA Engineer.
Thanks, Steve. Of course I can. CEngineer is a powerful software for the analysis and design of structures of every kind and any material. CEngineer can be used for the design of classical shape buildings, like this multi-story in Bucharest, or it can be used for the design of more unconventional shaped buildings, like this iconic museum designed by Zaha Hadid in Antwerp. CEngineer can be used for commercial and industrial frame buildings, like this exposition center in Belgium, or like this airport hangar in Turkey. Also, CEngineer can be used to successfully design iconic projects like this stadium in the Arabian Peninsula. And also, with CEngineer, it is possible to analyze and design pretty much every kind of bridge: steel bridges, composite bridges, and reinforced and/or prestressed concrete bridges. As you can imagine, in order to fulfill the very different needs associated to projects that can be so various, the software needs to have a large array of capabilities. Indeed, CEngineer offers many possibilities for the analysis and the design of structures. In what concerns the analysis, the software offers the possibility to perform other than classical linear analysis, also nonlinear analysis including material nonlinearities, geometrical nonlinearities, local nonlinearities, as well as global and local imperfections. For what concerns dynamic analysis, CEngineer offers the possibility to perform modal analysis, response spectrum analysis, and steady-state harmonic analysis. There is also the possibility to perform numerical backing analysis, both linear and nonlinear. And finally, CEngineer offers the possibility to perform construction stage analysis, so to correctly account for the effect of the sequence of direction of the structure. In what concerns the code-based design related to metal, CEngineer offers the possibility to design steel, aluminum, and composite structures. About concrete, CEngineer allows the design of classical reinforced concrete, prestressed and post-tensioned concrete, as well as fiber-reinforced concrete. And also, CEngineer offers the possibility to design timber structure, cross-laminated timber structure, and structural glass. So, as you can see, CEngineer is a very powerful solution for the analysis and design of pretty much every kind of building and structure. Back to you, Tim.
Mille grazie, Marco. Stunning to see that CA Engineer provides solutions for the structural analysis and design of any kind of structure. Before I close the session, a new version of CA Engineer will soon be available. Can you share with us a sneak peek of the new features that will be released in November with CA Engineer version 25?
Let me show you the main novelties introduced with CA Engineer version 25. Firstly, we introduced two new features on top of construction stages analysis. The first one is the possibility to perform design and checks on all the stages of the construction sequence. The second is the ability to perform backing analysis on all stages of the construction sequence. Then we introduced the latest revision of the American Design Code for steel structure, together with the latest revision of the American Code for load combinations. Additionally, in order to be able to tackle projects in which there are problems of human or machine-induced vibration, think a building with lightweight floors or bridges and footbridges, we introduced a new vibration analysis tool. This new tool allows to perform harmonic analysis given a single frequency or a frequency range, considering in-phase and out-of-phase nodal, line, and surface harmonic loading. It allows to extract acceleration, velocity, and displacement as results, both at peak and RMS value. It allows to use constant unrelated damping, and it allows to automatically attribute the sign of the load on the base of the selected eigenshape, shape, as specified by many buildings and bridge design rules. Finally, the tridimensional wind load engine becomes still more powerful with the introduction of three new features. Firstly, for the corner of the roof, the possibility to automatically select the zones with the most unfavorable pressure coefficient, so to avoid superposition of zones and have a more economical design. Then, for canopy roof, the possibility to generate the wind load on the base of the force coefficient other than the pressure coefficient, so again to have a more economical design. And finally, the ability to include in the computation not only the pressure effect of the wind, but also the effect of the friction, so to have a more realistic and safe design with respect to wind load. So, after this quick overview, back to you, Tim.
Well, Marco, great insights to what's coming next for CA Engineer in November. For more details regarding CA Engineer, feel free to visit our website at cia.net/en. With that being said, thanks again, Marco, for spending your time with us today, and take care. See you soon.
Thanks, Tim. Thanks, everyone, and have a nice day.
We will stick to structural analysis for now, but with the next speaker also kick off a bunch of sessions that focus on reinforcement design and detailing. Therefore, I would like to bring in Tamara Schäfer, Product Manager Integration at Allplan. Tamara studied civil engineering at the University of Applied Sciences in Stuttgart and started her career in a structural engineering office. She initially joined Frilo in 2020 as product owner for the Frilo BIM connector, and now shines as product manager for all interfaces between architecture and structural analysis within the Allplan family. In today's presentation, she will introduce you to the brand new interface between Frilo, our software for component-based structural analysis and design, and Allplan. Structural engineers will be able to calculate the required reinforcement for reinforced concrete columns and transfer the results to the Allplan model, where the reinforcement is inserted at the click of a mouse. Tamara, before we start your presentation and show the software, how do structural engineers benefit from the type of interoperability between Frilo and Allplan that you are going to show us?
Yeah, welcome everyone from my side too. That's a good question, Tim. The new interface makes it possible to transfer the calculation results available in Frilo to Allplan. And this means that the structural engineer does not have to enter the data twice. And yeah, that's why input errors are reduced and you reach your goal, a finished reinforcement plan, more quickly.
That actually sounds super powerful. So let's dive into the software and learn how to make use of this very specific and new workflow. Tamara,
Yeah.
The stage is yours.
Yeah, sure. Yeah, thanks, Tim. Today, I'm very happy to present the new interface between the Frilo reinforced concrete column and Allplan. In order to better understand the interface between Frilo and Allplan in the overall workflow, I have summarized the entire workflow between Allplan and Frilo on this slide. We have already demonstrated the workflow highlighted in blue here in several webinars, so that means the exchange of an overall model between Allplan and Frilo. Today, I would just like to talk about a newly developed interface between B5 Plus and Allplan. And yeah, for the workflow, a model in Allplan is required, and this must also be saved on BIM Plus. I would also like to take this opportunity to point out that this is a technical preview. This means that you are welcome to give us your feedback, and we will use this to improve the interface over the coming months. In addition, we also want to develop further interfaces between individual components of Frilo and Allplan, over the next few years. And for example, an interface from the continuous beam or the foundation to Allplan would also be possible. So, but now let's jump straight into the Freelo application and take a detailed look at the workflow. In B5 Plus, the column must first be defined and analyzed. The required reinforcement is then displayed at the bottom right, which can then be inserted into the column using the reinforcement dialog. B5 Plus offers an automatic placement of the reinforcement for this purpose, and in this example, I have decided for a distributed placement. And after that, we can close the window. The calculation can then be started again to check whether the placed reinforcement is sufficient. If the design is now correct, the column can then be transferred to Allplan. The data is exchanged via BIM Plus, and you therefore need a BIM Plus access. And you will find the transfer to Allplan in several places in the interface, for example, at the top in the center. Firstly, you must log in to BIM Plus with your access data, and you must then select the team, the project, and the model to which you want to attach the reinforcement. For the exact assignment of the column in Freelo to the column in Allplan, you need also a unique ID of the column, and therefore we use the IFC ID. For support, you can start the BIM Plus web viewer, and there you have to select the relevant column. And in the property menu on the right-hand side, you can copy the ID of the column. Now switch back to B5 Plus, and here you can enter the ID in the corresponding field, and the green icon shows you that the assignment was successful. And now we can place the reinforcement in Allplan. And to do this, let's jump to Allplan. And first of all, I will reduce the view of the building of the columns to have a better overview. And in the engineering structure area, you will find the automatic column reinforcement functionality. You must now select the same column from the project again, and on the left-hand side, you can now import the transferred parameters of the column from Freelo. You will be informed again that this is a technical preview, and you have the opportunity to send us your feedback directly from here. And further dialogues will then appear. These will tell you what could not yet be transferred. For example, the sidebars are currently distributed uniformly over the column side because corner concentrated reinforcement cannot be transferred yet. And the next dialog tells us that the inner stirrups cannot yet be taken into account either. But in the coming weeks and months, the automated reinforcement at Allplan will be improved in this direction. And last but not least, I would now like to compare the two results again. And here on the right, you can see the column from Freelo, and on the left, the column from Allplan. And it's already looks pretty similar. For me, it's really cool how easy it is to transfer the reinforcement from one program to the other. And as I said, this is the beginning of more interfaces between Allplan and our structural analysis programs. So I have now reached the end of my presentation, and I would like to hand the words back to Tim.
Thank you, Tamara. It was great to see how Freelo and Allplan already interact. The merger begins to bear its first fruits. Therefore, I want to know, and I guess also our users want to know, when will Freelo and Allplan users be able to actually benefit from the new feature?
That will still take a little while. Our users will be able to try out the workflow for themselves from mid-November. Why from mid-November? we will publish the new Freelo version in mid-November, and yeah, from then on it will be possible to test the interface. You may also have noticed that the languages in the dialogues switch between German and English, and this is because we have been given you an exclusive insight into our development today. However, everything will be translated by the time the new version is released.
All right, I think that is a valuable and important information for our users. Let me thank you once again for kicking off the reinforcement block of the event. It was great having you. Take care, Tamara.
Yeah, thank you. Bye.